Hi everyone, thanks for joining. Today we are going to talk about fine tuning models. This is the last and concluding session of this series, and so far we have covered two sessions on RAG, uh, small language models, and a very practical use case where we leverage GenAI for end to end analytics. Today, our focus would be how we can customize a GenAI model. Approach, as usual, would be concepts supported with technologies and demo. And these sessions are meant for anybody who's interested in understanding the conceptual aspect of GenAI. We just like to cover things at a very conceptual level only, just to make sure that everybody is able to understand. But I'm happy to take this session to more detailed level if required. I use Azure platforms basically to leverage the models which are hosted on Azure, so Azure OpenAI models. But whatever I discuss and what all sessions I've covered so far, uh, it the approach is agnostic to model and cloud providers. You can use the same approach for AWS, run GenAI models on other model provider platform like Claude, Gemini from Google. I use open source technologies, which includes frameworks, languages, and toolset. The idea is you can leverage it in any way you want. There is a LinkedIn group called AI Mantra. If you are not part of it, feel free to join. I post um, good insights and market information for the benefit of the community. This is the third series, and in the past, I had run two series in April 2024 and December 2023. All the material is available. You can also go through it in case you missed some of the session. The links to all the material is in the invite. Feel free to make use of those recordings in case you want to start your journey now. Today we want to talk about fine-tuning language models, and the approach is applicable to both large language model as well as small language models. So let's see what is there in fine tuning a language model. Now, fine tuning is a process where you take a pre trained model like GPT 3.5, GPT 4, Llama, and then you train it further by providing a smaller domain specific data set to ask model to behave or train the model to behave in a certain way. So you're basically customizing model by providing a data set that is specific to your task or domain to create another model which basically is independent of the base model or foundation model. And we'll see why you would like to do that. Now, in order to understand fine tuning, let's take a very simple example. So you have students who graduate by doing MBBS, they become doctor and they learn everything. They are kind of journalists. And if you want them to really be specializing in some specific field of medicines like cardiology, neurology, they undergo another set of learning or training specifically focused around this set of domains to become specialist. And this is the same approach which is used for fine tuning model. You take a foundation model, fine tune it, and becomes a specialized model for a given task. Now, fine tuning model is much simpler. Now, if you look at the diagram, you basically take a large common data set, the data from public internet, Wikipedia pages, white papers from archive. You train them to create a source model or a foundation model. Now use this model by applying a smaller data set which is specific to your domain to create a fine-tuned model targeted to your requirement. So basically what you're doing, you're adapting the language model for a given task in order to increase the performance. Now before we actually see how a model can be fine-tuned, let's look at what goes in terms of training the model in the first place. What I have here is Llama 2 70 billion parameter model, which was trained on 10 terabyte of data from the internet. And in order to perform the training, you required something like 6,000 GPUs that ran the training for 12 days, costing around $2 million. And as a result of it, you have a model which is 140 gigabyte, and that basically is the foundation model. Now, you cannot afford to do it for the specific domain that you are targeting. It could be customer support or anything which is specific to your requirement. And that's where you can create a fine-tuned model by taking the base model and steering it to behave it in a certain way to create something which is suitable for you. Now, let's look at why and when to fine-tune a model. You all know prompt engineering gives you a good response from a GenAI perspective by providing the prompt and the context, which is good enough. However, you may like to use other techniques like RAG and fine-tuning. And RAG we have extensively covered in the first two sessions of this series. In RAG, what you do, because the model has been trained on the data which was available from different sources, if you want the model to utilize a context which is not there in the training set, you provide a context inline as part of the prompt. And that way you can get a good response. But sometimes you may require for a model to be behaving in a certain way to performing a task which is suitable to your requirement. And that's where you do the fine-tuning. Now, all these three techniques are complementary. That means you can use a combination of them depending on your requirement. So, in prompt engineering, you design prompts, provide the right context. In retrieval augmented generation, you retrieve the data from external sources and incorporate them into your prompt. And this data can be coming out from live systems or the data which was not available at the time of model training. Essentially, your private data can be supplied in the context. Whereas in case of fine-tuning, you basically train the model. So in prompt engineering, the context goes inside your prompt, whereas in fine-tune, you basically provide the context to the model so that you don't have to do it every time. And that's where fine-tuning is really useful. If you look at this, you can combine all the three techniques: prompt engineering, RAG, and fine tune based on your your needs. So the important question is why we would do the fine tuning and what are the benefits of fine tuning. Fine tuning helps you improve the performance in terms of a specific task, because the foundation models are generalistic in nature. If you want to customize the model to act in a specific way based on your requirement, you'd like to fine tune, and you really don't have to provide a big context once you fine tune, which results into a higher efficiency and also takes care of the limitations that foundation model has of not knowing your organization or your domain context. And after fine tuning, your model is basically tuned or customized for a given domain. Now let's understand how the models are trained in the first place, because a similar approach is used for fine tuning also. So there's a concept of forward propagation, backward propagation, and calculation of the loss function. In case of forward propagation, which is basically applied on the neural network, uh, you have basically data inserted in what is called as neurons. There are multiple layers of neurons, and you essentially train them in terms of the parameters which are weights and biases. And then as a result of it, you get some outcome, a predicted value, which you compare with what is the expected or the true value. And the difference of these two is the loss function. So the model training is an iterative process. And what happens after the first forward pass, you compare and then you give the feedback through the backward propagation, and the model undergoes the next set of iteration till the time the loss is minimal. And that's how the model training happens. And the same principle is applied for fine tuning. One of the tool that you can use for fine tuning is an open source model optimization tool called OLEP, and it can run on GPUs, CPUs, and it can really provide a desired outcome with very low resources. This technique called QLoRa, which is quantized low rank adapters. It's a method of fine tuning large language models efficiently. And what it does basically, while it is fine tuning, it is quantizing. Quantizing is essentially reducing the memory requirement both at the storage as well as RAM level, because of a smaller footprint due to reduction of the bytes that is required from, let's say, 16-bit to 4-bit or 8-bit, with very little compromise in terms of performance. So basically it's a trade-off. And after quantization, you get a smaller model that you can run locally without actually compromising the accuracy, and that way you can have the benefits of privacy, lower costs. Now, what we will see in the demo, I've created a data set. And if you look at the data set, it is nothing but a set of name value pairs. It's in a JSON lines format. So you have basically a question and an answer, and you have series of this type of questions that we will be using to provide as a data set for fine tuning. I've purposely chosen the same data set I've used in the previous session also, just to be making it simple for you to understand. You can do fine tuning in the cloud, and you can do it locally. I'll show you both. So you can use Azure OpenAI Studio or Azure AI Studio to fine tune. And let's understand what is the fine tuning process on Azure. So what you basically do, you choose a pre-trained model or a foundation model, prepare your data, the example that I've shown you in the previous slide, upload the data, configure the parameter for fine tuning, run the fine tuning, and that's it. It's a very simple process. Everything happens behind the scene. And once your model is fine tuned, takes a couple of hours. You evaluate the model, and if you're satisfied with the performance, you can deploy and make use of the fine tuned model in your GenAI app. Okay, so let's look at the fine tuning process. Now, just to illustrate the need for fine tuning, let me just show you something. So I've got two models, same model, GPT 3.5 Turbo. One is on Australia East, the other one is in US East, US 2 East. And let's understand why we need to train the model. So I've got a very basic question about me, which city I'm based. So if you ask this question, the foundation model GPT 3.5 Turbo doesn't have any clue, because this model is not trained on the data on which I'm asking this question. Now let's understand the response with the fine-tuned model, and I'll explain how the fine-tuning is done. If I ask the same question and the model is able to give me the right answer, and let's understand why this happened. Now, both are based on GPT 3.5 Turbo, but this model, which is hosted in East US 2, is a fine-tuned model. Let's ask another question just to validate. And I've got this set of data for which I know the exact correct answer in terms of accuracy. It doesn't have an answer. Whereas if I ask the same question, it is able to tell me. Now this happened because of the fine tuning. And let's look at how fine tuning is done. So in order for you to fine tune a model, you definitely need a data set. Now this data set can be divided into a training and a validation set. And what you do, if you look at what are the models which are available, these are the base models, and I can choose to customize or fine tune any of these models. And the way I would do it, I'll say create a custom model. You use a base model. I won't do everything because it takes a couple of hours. I've already fine tuned like I've shown you before. So you choose the base model which you would like to fine tune. Then you choose the training data set. So I've used this training validation data set, user line. You choose that. You choose optionally a validation set, and then you try to customize in terms of number of epochs, batch size, all that. And that's it. When you hit start training job, it will start tuning the data based on the data set that you have provided. Very simple, very easy. And as a result of it, what you get is a fine-tuned model. And you can see the base model is GPT-3.5 Turbo. But now this model has the context that I provided in the form of a data set. And that's it. Not very difficult. The innovation in this is how you choose your data set that goes as part of the fine tuning. Rest everything is mechanical. So that's how you do the fine tuning on the cloud. If you have to do it locally, which is you want to do it on your server, on your laptop, and assuming that you have the required capacity in terms of GPUs, memory, and all that, you should be able to do it on your device or a server, and we'll see. So let me just launch Visual Studio Code. So this was the data set that I was talking about. So in Visual Studio Code, Microsoft provides you what they call is an AI toolkit. It is an extension to the Visual Studio Code. And what you can do, just install that extension and choose this option called Model Fine Tuning. Create a project. Specify the location of your project files. Choose a curated model, which would be the base model. Let's say we take 5.3 and you configure the project. So what it will do, it will basically create a project with the code that is required for fine tuning. It will also provide you a data set that you can, a sample data set, and you can actually create your own question and answers pair. And then depending on whether you have the required GPUs on your device, you may choose to fine tune it. And that's it. Then you generate the project, and let's see what is there in this project. So let me open that folder. Now, if you look at what is there, the most important thing, like I said, when we were doing the fine tuning the cloud, is the data set. So it provides you a sample data set, which is this is used for some sort of a sentiment analysis. If a phrase is like this, what will be the tone? So you are providing that level of understanding in terms of sentiment analysis to the model so that it can actually perform a sentiment analysis and give you a tone as a result of providing some prompt with this text. Once you do that, you have a Python code some configuration and you run this code, as a result of it, it will create a model which is trained locally on your infrastructure. And that's pretty much I have. Just to sum it up, you can fine tune a model to behave it in a certain way by applying a data set which is specific to your needs or domain, so that the model can give response the way you want it. You can do this fine tuning in the cloud where you're leveraging platform like Azure, AWS, or you can do it locally if you have GPUs. And the most important thing that you have to provide is the data set. And thus everything is mechanical. Thanks.